the load and the duty on existing boilers, and thereby reducing emissions levels as well. Now, this particular project was a waste heat project at the Port Arthur Steam Energy in Port Arthur. Basically, it's a 60 megawatt CHP plant which produces 5 megawatts of electricity and 55 megawatts of equivalent steam. This particular project is purely a waste heat recovery project where you had heat being wasted into the atmosphere. That heat was recaptured and steam was being produced and exported through a 2.5-mile steam pipeline. Now, the reason why we call waste heat as zero emissions, it has as much emissions as wind energy, primarily because you have the systems in place, you have things that have been permitted. All you're doing is you're capturing the waste heat that is going into the atmosphere and you're using that for useful work. As a result of this, you had 5 trillion BTUs per year which is being captured. You had 280,000 tons per year of carbon dioxide which was offset. You have 200 tons per year of NOx that was offset. Now let's look at the most recent project, the BP Rodeo and Helios Plaza in Houston. You had a 4.3 megawatt CHP plant. The prime mover in this case was a gas turbine. It was connected to the heat recovery steam generator. You had 1350 ton absorption chiller and a 4,000 ton hour thermal energy storage tank. The system was connected in a way such that it had dual electrical feeds. It was base loaded by the gas turbine and it got about 100 kW from the utility. And, because of all these efficiency improvements and the CHP plant, the BP Rodeo is all set to become the first LEED Platinum building in Houston. Let's talk about the Methodist Hospital, which is going to come online sometime in May or June. You have a 4.5 megawatt CHP plant fueled by a gas turbine. You have a heat recovery steam generator with a duct burner. It's capable of producing 50,000 pounds per hour of steam. It's connected to a steam chiller, which is 2,800 tons. The drivers for this project was primarily campus expansion and emergency preparedness. As we have seen before, CHP in the time of hurricane operates almost unaffected, and there are lots of anecdotes with regards to the reliability and security that CHP provides. As a result of the installation, we had 70% reductions in NOx. This project also is qualified to receive energy efficiency incentive from Centerpoint Energy through its large CNI standard offer program. Lastly, let's look at UT Austin. This basically is a graph that shows you annual carbon dioxide emissions in tons over the last 40 years. Basically, even though the campus doubled in the square feet and there was huge campus growth, as of 2010, the emissions level is now the same as 1977. And that was made possible only due to the CHP plant, utility improvements, and an aggressive energy management system targeting efficiency and environmental benefits reductions by the UT Austin management. Briefly, it has a 137 megawatt combined cycle plant. It has combustion and steam turbines. It meets all of UT's electricity, steam, and chill water needs. Basically, Austin Energy is connected to UT Austin and serves as a backup to its existing CHP plant. Now, to summarize, CHP is a proven technology that has been around for over a century. There are conventional systems available at reasonable costs. Prime movers and waste heat capture mechanisms has significantly improved in the past decade. It reduces utility costs. There is drastic reductions in greenhouse gases, and it provides energy security and reliability. And let's move on. Where can we find more information with regards to CHP? We have our website, the Gulf Coast Clean Energy Application Center. It is independent CHP, unbiased CHP assistance. Lots of resources with regards to technologies, applications, case studies, and information is there with regards to clean energy on our website, www.gulfcoastcleanenergy.org. You have the Texas CHP Initiative, which is basically your CHP industry association. Consists of all manufacturers of major prime movers and some engineering firms and quite a few people in the initiative who have years and years of experience when it comes to designing or building CHP systems. Also, you have the U.S. Clean Heat and Power Association. You have the U.S. Department of Energy CHP program. You have the U.S. EPA CHP partnership. And finally, here is our contact information. You have Dan Bullock, who's the director of the Regional Application Center. You have Ross Tomlin, who provides for policy support. That's me, Krishnan Vamayeshwar. I'm pretty much into technical assistance and project support. And in case you have any administrative queries, you can contact Jenny Jan. And I guess we are finished up quite slightly early ahead of schedule. So we're going to keep the floor open for about 5 minutes more for any additional questions that you may have. And in case you have any further questions, please feel free to contact any of us. And I would like to thank you for attending this webinar. We are going to offer several more webinars in the upcoming months, which is going to target specific areas of importance with relation to CHP and clean energy.
Thank you. Please stand by.